7 Caillou. This one's called Numbers with this digit inside. You have to search all numbers from inclusive 1 to inclusive a given number x. You can see provided as a parameter to the method that have the given digit d in it. The value of d will always be between 0 and 9. The value of x will always be greater than 0. You have to return, as an array, 3 pieces of information. The count of these numbers, how many there are, their sum, and their product. For example, consider x is 11, d is equal to 1. The numbers you get, if you start from 1 and enumerate all the way out 1, 2, 3, 4, 5, 6, 7, all the way up to 11, you can see that there are 3 numbers you'll encounter that have the digit 1 in them. 1, 10 because of the first digit, and 11, which has 2 ones in it. And so you'll return the count. The number size is 3, right? So you put 3 in that first return value. If you add them up, you'll get 21 plus 2 is 22. And if you multiply those, 11 by 10 is 110, times 1 is still 110. And that's where you get the third value. I think that's pretty clear. If there are no numbers, which include the digit, return the array 0, 0, 0. Have fun coding it, and please don't forget to vote and rank. Yeah. Let's get to it. Go ahead and pause and try this one out, and come on back when you're ready. So you may want to, as a first step, if you want to enforce that d will always be 0 to 9, you could do that x is greater than 0. First things for me, I want to rename these, so I'll call this one max, and I'll call this one digit to find. It's a little more sane to me. And I want to point out, look for parameter d here, right? It's always between 0 and 9. What the heck do you need a long for? Even a regular int is complete overkill, but a long, I don't know why they did that to us. But here we are. So let's get to it. If, what'd they say? Value of x will always be greater than 0. If max is less than or equal to 0, or d is less than 0, or we renamed that, didn't we? Digit to find is less than 0, or digit to find is greater than 9, right? Any of these cases we have a problem. We'll just say throw new argument exception. I'll just say bad input, but you'd put something meaningful here. I'm gonna go ahead and bring in the system namespace already, since I'm using that argument exception class. Okay, so do whatever kind of parameter checking you need to do, fine. Next step, we are going to, maybe I'll go ahead and initialize that output array, right? And they said they want it as a long array. I often call what I'm returning result. I'll do that. I'll say new long array, and we'll initialize it with 0, 0, 0. Okay. So that's good. And then if we have, what did the case? They said if we had some kind of bad input, we just return the 0, 0, 0. If there are no numbers which include the digit. So we can add something to sort of short circuit. If we hit that case and just exit early with that empty, well, not empty, but full of zeros, long array. So I could say something like, if max is less than the digit to find, right? That would be a problem, right? You're certainly not going to find a digit if max doesn't even go up to it. So you could just say return result. Okay, that's pretty good. Next, let's go ahead and we've done this in previous videos where we've had to get the digits from integer values. And so let's go ahead and make a little helper method to do that for us. It'll come in handy. Static, this has nothing to do with objects or object-oriented programming, right? So that's why I chose that. I'll represent the digits in a list. I'll say get digits from int, something like that, int n. And do you remember how we do this? That'd be good if you could even pause at this point and implement this if you like. Be a good practice. Could add some protection here. If n is less than 0, throw new argument exception. This should never hit. More bad input, but you'd want to put something professional there, right? That's a quick warning to you when you get in professional environments. Don't try to be cutesy or funny with your comments and messages. It's bad practice. So yeah, we have a list of ints, and we call it digits. We'll initialize that so we can work with it. That's good. And then do you remember the little, how we used to do this? While n is greater than 0, right? And we use our friend, the modulo operator, to sort of peel off the least significant digit at any time. So we could say digits add n modulo 10, right? Gives you the least significant. And then you just got to be sure that you're updating 10. N divide equals 10, which is the same as saying n equals n divided by 10. It's just a shorthand. I think you're getting comfortable with that by now. So yeah, that'll update each time. It'll terminate the loop when all those digits are peeled off and n goes to 0. So then you can finally return your digits. And that should be good. We'll find out if it's not. But this will be smooth and help us out a little bit for our purposes. So it's good to do that. So let's go ahead and try to find the digits that we need first. And so I'm going to call these the numbers, or maybe we should call them matches, right? What I'm going to start by doing is using our old friend enumerable range, right? And we're going to start at 1. They told us inclusive 1 on the low end, and then up to max. And because max is guaranteed to be greater than 0, this shouldn't cause a problem. So I'll put max in there. It's going to give us, 1, 2, 3, 4, 5, all the way up to max. That's what this whole bit will do right here in some kind of enumerable of long collection here. So we've got that range, right? And so now we're going to filter it, right? And do you remember the link method that we use for filtering? That would be where, right? And we get to provide a condition to say which values from the collection that this is invoked on get through and filter out the ones that shouldn't make it. We give it the condition that allows input elements to go through. So we can say we're going to use a lambda expression for that. We have a single parameter, right, an n representing all of the longs in that collection. And then we can use our helper method now, right? So we can say, we can call get digits from int on each of these elements, right? So we're going to start at 1. We're going to say, hey, get the digits for 1. And it's going to give us just 1, right? And then we got to match, right? And I'm going to use another one of these link methods to check, hey, does it contain a certain value? And the value I'm checking for is digit to find, right? And so that's sort of my condition. So what do we have here, right? We made the range of numbers 1 to max, and we said, hey, all right, great, you got that collection. Now give us another collection. We don't want all of them. We want it where for any element that you give us. We're going to get the digits from it, the individual digits, which is going to be this list, right? This method, we defined it. Look down here, list of integer. If it contains the digit to find. And if it does, let it through. If it doesn't, then you don't let it through. As simple as that, right? So that's good. We've got, you can think of that as the equivalent of this statement over here, right? Now you get your numbers collection. I call that matches. That's fine. So next we've got to, once we have our matches, we've got to populate the result array that we made, right? So let's do that. You could do, we've got 3 of these. So you could say result 0 equals matches dot count. And I know it's confusing, it's really inconsistent. I don't like it that some of these collections have count to get the number of elements. In arrays you've got length, and it's kind of a unfortunate design choice by people. Anyways, what goes in the second slot? It was the sum of all the numbers, right? Do you remember how you can do that with a collection? With your IEnumerable collection? You can say matches.sum, right? And you can go to the docs and look these method up, right? We've done that in the past, and you're well equipped for that now. And so what does the last one contain? Well, it's the product. And we can't say matches.times, right? Or product, right? So we got to be a little more clever than that. There's another enumerable method that you can use that's very generalized called aggregate. And hopefully you remember this one. If not, go ahead and look it up. What do we have here? Let's see what we have. C# aggregate. Let's go check it out. Enumerable aggregate method. Good. And so this is sort of what we want. I'll just shortcut you right to the examples that are helpful. There's a better one in here. This is a little more what we're looking for, right? Aggregate. So you get to seed it with an initial value, and you, as you can imagine, for a product we don't want to use 0, right? Because if you multiply anything by 0, you're going to get 0 for your final result. 0 is great for adding. If you're multiplying, not so great. So we're going to seed ours with 1, and then we get to define these 2 parameters for our lambda function. Remember, they have parentheses now because there's more than 1. And so the total will represent this seed value, right? As you process through this aggregate function, the total is going to keep getting added to, so you get the current value of it at any time. And then next would just be the next integer in this collection. So it'll start at 4, then 8, then 8, 3, etc. And then you process it however you want. As you can imagine, we're going to, for each value we encounter, keep multiplying it by the total, starting with the seed value. So let's use it in a manner like that. Let me see if I can get back to the right window here. Oh man, I got too many tabs open. There we go. Okay, so matches, aggregate. We want to seed with 1 for the reason I told you. And then we're going to make our parameters. Instead, they use total. You can use total. I'm going to call mine a product since I'm multiplying. And then I'll just use n. It's a generic variable name I like to use for integral values. So we made our parameter list of our anonymous function, right? And now we've got to do the body. It's like, what, you got to do your work now, right? So for our case, we simply want to multiply the product by n. And it's going to go through the whole collection, starting from 1, 1 times 1, that's 1. Then you're going to multiply by 10. 10 times 1 is 10. Then you're going to multiply by 11. 10 times 11 is 110, if we go with that example. So that's sort of how that's going to work. This isn't quite, you'll see this isn't quite right. It's a little off, but we'll address that. And then finally, once you've populated all your values, you should be able to return the result. Now, I've used list in that get digits from int, and so we know, hey, we're in trouble if we don't bring in system collections generic, right? A lot of those list and other collection types reside there. And then we're doing some link stuff too, so why don't we go ahead and bring in using system link. And who knows what other errors I made, but we'll get those out of the way because we know we're getting yelled at if we don't bring those in. And we don't like to be yelled at. Okay, argument 2, cannot. Yeah, so there's some shenanigans with these long ints. Well, that's okay, we'll fix that. It says line 17, right? And so let's go with, let's fix it so we're dealing with longs. Line 17, spot 39. Where is it? I should probably call, let's see if this needs to be long. 1736 cannot convert from long to int, 45 and 90. So max was a long. Oh, you know what? Let's do this. To help out, I'm going to make int, let's call it to find int. And I'll just convert this to an integer since that's all I need here. I'll go convert to int 32, digit to find. And then I will start referencing this. What else did I shouldn't actually, that should be fine there. Let's do that. Did I use it anywhere else? Convert this to long. Let's see where this gets us. Argument 2 in line 18 cannot convert from long to int. I wonder if, oh, I wonder if I should have used long. Actually, no, I don't think that's okay. I definitely want it for aggregate, right? Because you're going to have this big multiplication with a possibly some big numbers. All they really told us was that it's going above 0. Where n contains int n, what else I do? Oh, you know what? I think I see it. This is a long, right? We've got an int here and a long here. So, you know, I can convert to int 32 max. Let's try that. I suppose I could have counted out the 39. Okay, that looks better with the last error. I think I've mentioned that to you before, but if you want to see that. The second part, you know, the first one's a line number, the second one tells you it's at 39. So if you're ever not sure, you can just start at the beginning of the line, count out your 39 spaces, and you should get to where it thinks the problem is. But I'll go ahead and redo that. Sorry about the int and long conversion shenanigans there. Okay, we got green on the test. Let's try the attempt. Okay, basic test failed. Values differ at index 2. Expected 0, but was 1. So I might add some logging state. Oh, sure. I know what I did wrong here. I warned you that there was a problem where this wasn't, this bit wasn't quite complete. You could add some console printing statements here to see what was going on, but if you want to pause and do that, go ahead. Otherwise, I'll just put the fix in. But we have cases where matches.count could be 0, and that's a problem for doing this multiplication. So if I say equals 0, right, in that case, if there are no numbers, right, we've got this empty array of zeros. Matches count equals 0, I'm simply going to return 0. Let's try this. And that looks better. So yeah, I missed that. You want to make sure there are values to multiply, right? Otherwise, we're kind of saying our seed value was 1, right? And isn't that what the error showed, was that there was a 1 where a 0 should be? Let me go back to that. So yeah, expected 0, but was a 1. And this is at index 2, right? We know index 2 is the product. So yeah, it was probably trying to do this multiplication where it had the seed value of 1. There was nothing to multiply, so you're still left with the 1. And it was assigning it there. And so we got 0, 0, 1 as a result, where we should have had 0, 0, 0. So let me put that back in. Yeah, if you weren't sure, you could write console write line, and then print out these values that you're getting. What are the inputs you have? I'll go ahead and submit mine like this. Looks good. I don't think that no comments I need to take out. I'll go ahead and submit mine like this. Go ahead and submit yours, get your kata points. You earn them. Even if you didn't figure it out on your own, you know, you're working through the challenges, that should count for something. And so yeah, go ahead and look through. There's certainly people that got nice compact answers. That's not always the best in my opinion, but you can certainly see that. Otherwise, hit me up if you have any questions or concerns, and I will see you in another video. Thanks.